OK, so in this problem, what we need to do is we need to first to be able to describe the discriminant, and then what we want to do is be able to describe the roots of the discriminant. So the first thing, ladies and gentlemen, is we need to determine what A, B, and C are equal to. You don't have to do that for your answer. But as far as my process goes, this has been very helpful as far as students learning to make sure they're doing it correctly. So to understand my A, B, and C, I have ax squared plus bx plus c. Remember, a is going to be my coefficient of my quadratic term, so it'll equal 5. B is my coefficient of my linear term, which in this case is -1. And c is my constant, which is also -1. So now what I simply need to do is determine, well, what is the value for my discriminant? The value of the discriminant for A, that's part A of my problem, is b squared minus 4 times a times c. All right? So what I'm going to do is just going to plug in my values. So I have -1 squared minus 4 times 5 times -1. So -1 squared is a positive 1. And then I have -4 times 5, which is a -20. -20 times -1 is a positive 20. Because c is just going to be your constant. So you can see it's -1, so that would be, so it's a -1. So that's why c is -1 up there. Because instead of it being plus c, because you can see that's being, that negative x, that x is being multiplied by -1. Right? Because 1 times 4 is equal to 4. Right? We don't write the 1 in front of there. We just have it there. Does that make sense, Courtney? Because you really have my red pen that I was looking for, so I'm wondering where that went. Anyways, so we go ahead and we see our value of 21. Now, the next step is we need to describe our root. All right? So we look at the first thing. Is it a square number? Right? Our square numbers are 1. Huh? 4. That's part of your, that's the rule for the discriminant. B squared minus 4 times a times c. That's the rule. So anyways, we look at first our square numbers to determine if we have a square number. Our square numbers are 1, 4, 9, 16, 25, 36, 49. Is 1 a square number? No. Then the next thing is we look at, all right, so it's a non-square number. Is it positive or if it's negative? So it's positive. So therefore, our solutions, when we look at our rule, since it's a non-square number and it's positive, we're going to have 2 real irrational roots. Okay? Now you guys might say, well, Mr. McLogan, how do you know it's going to be irrational roots? Well, let me go and explain part C now.